Low-precision training hits stride. NVIDIA's NVFP4 pushes 4-bit pre-training from an experiment to a credible default. The format isn't a flat FP4. It uses shared FP8 E4M3 scaling at a microblock level. 16 values share a scale, extending per-block dynamic range to roughly 0.001 to 2700, while keeping the I/O and memory savings that make 4-bit compelling. In a reported run, a 12B parameter Mamba transformer trained on 10T tokens in NVFP4 tracked FP8 within 1% validation loss for most of training, drifting to 1.5% late in decay. Downstream deltas were small: MMLU Pro 62.58% NVFP4 versus 62.62% FP8, with a modest dip on coding, MBPP 55.91% versus 59.1%. The broader takeaway echoed by practitioners: structure and scale often matter more than per-weight precision, and careful blockwise handling and outlier control let aggressive quantization pay off. NVIDIA's blog copy leans 16-bit precision with 4-bit speed, but the evidence presented is near FP8 accuracy at 4-bit cost. Enterprise-aimed open models are also leaning into efficient designs. IBM's Granite 4.0H Micro 3B blends attention with Mamba 2 for long context, 128K, improved instruction following, tool calling, and multilingual ability, while maintaining a compact footprint. Notably, training ran on a GB200 NVL72 cluster with 400 gigabps NDR InfiniBand, underscoring how hardware interconnects, not just GPU cores, now bottleneck or unlock training efficiency at scale. On the inference side, OpenVINO shows how much is left on the table without platform-specific optimization. A small VLM, converted to OpenVINO dropped time to first token from over 5 s to 0.42 s, and raised decoding throughput from 0.7 to 47 tokens per s on Intel CPUs. 8-bit weight-only quantization pushed it further, and static quant on the vision encoder added gains when answers are short or inputs are multi-image. The pattern mirrors NVFP4's logic. Right-sized precision in the right places yields most of the speedups with minimal accuracy loss. For local deployments, it still pays to respect the VRAM ceiling. One developer testing NGPU layers on a 16GB RTX 5070 Ti found inference time jumped sharply once GPU memory was exceeded, a reminder that spilling to host RAM kills latency. If you want longer context windows, stay under the VRAM-optimized layer count first or pay the performance tax. Big multimodal models keep scaling, but they also depend on all of the above. Qwen3VL's latest 235B MoE Instruct model claims 256K context, expandable to 1, stronger video temporal modeling, and improved spatial grounding, while recommending flash attention 2 for acceleration. Another reminder that efficient kernels and memory-aware formats are now first-class design choices, not afterthoughts. Practical multimodal in the wild. OCR is finally practical for many day-to-day tasks, but not magical. Users working with NanoNet's OCR23B report big wins. Financial reports convert to decent markdown tables with cleanup. Academic PDFs produce clean title, author, abstract with mostly structured references. Clause hierarchies in contracts make search useful. The model still stumbles. Subtotal mislabeled as total, 8, read as B in compressed scans, and skewed handwritten receipts remain hard. Pragmatic tips help. Avoid overcompression. Keep the long edge, 1280p econ. Specify tables in Markdown and math in dollar. And don't stitch many receipts into a tall image. Localization degrades. Benchmarks vary. One user's bank statement pipeline saw NanoNet's missed table structure that a small Mistral Q6 handled well. Asking for Markdown instead of CSV may improve results. Reality check. Prompts and input hygiene often matter as much as model choice. Model claims are rising too. Qwen3VL touts expanded OCR in 32 languages, better handling of blur, tilt, low light, and improved long document structure parsing, alongside upgraded recognition across celebrities, products, flora, fauna, and more. Those capabilities look directly relevant to the failure modes users cite, but, as always, marketing claims need to be verified on your own data. Video agents are getting more end-to-end. Paper2 Video, PaperTalker, chains multiple agents to turn a paper plus a reference headshot audio into a full presentation with slides, subtitles, synthesized speech, cursor movements, and a talking head. It ships an MIT-licensed pipeline and a benchmark across 101 paper-video pairs with metrics like meta-similarity, present arena, present quiz, and IP memory. Today, it runs best with GPT 4.1 or Gemini 2.5 and a beefy GPU, A6048 end-to-end. The community is already asking for a base URL config so local models can slot in. Audio is joining the on-device movement. New TS Air bills itself as a super-realistic, on-device TTS with instant voice cloning from 3 seconds of audio. Under the hood, a 0.5B Qwen-based backbone, a 50 Hz neural audio codec, 2048 token window, 30 seconds of audio with prompt, and GGEONX paths for real-time generation on laptops and even Raspberry Pis. The repo stresses clean reference audio and ships examples. Also, beware imposter websites. For researchers, Xiaomi's MIMO Audio Eval brings a unified toolkit to evaluate pre-trained or FT audio language models across multiple datasets and tasks, including scripts to reproduce paper results and practical notes like pre-built flash attention wheels. Together, these signal a push toward robust, reproducible audio agents that don't require a cloud round trip. Agents wrestle with async tools. Real-time agents still struggle with long-running tools. One developer found that when a tool takes seconds or minutes, sequential model behavior forces the assistant to stop talking or cancels the call if interrupted. An orchestration pattern like Pipecat's async tool calls kinda worked with one model but broke others by retroactively injecting results into past turns. Practical design ideas from the thread mirror concurrency patterns. Return in-progress handles, promises futures, make the conversation itself asynchronous so tools can post results later, or fork the conversation into pre-result and post-result branches and join them deliberately. None of this is free. It's the cost of turning a turn-based LLM into an event-driven system. Reasoning parsers add their own wrinkles. A VLLM setup serving GLM 4.6 FP8 with a GLM 45 reasoning parser kept leaking think tokens. Switching templates to nothink by default, enable with /think, helped in a related GLM 4.5 case. The meta lesson: your chat template, parser, and thinking conventions must align, or you'll ship hidden chain of thought to users. Dev tooling is adopting plan first, act later. A plan mode for OpenAI's Codex CLI appeared in a public video and PR, prompting comparisons to IDE agents like Klein that draft a multi-step plan before editing code. That pattern is more than UX sugar. Teams describe it as spec-driven development, a lightweight guardrail against vibe coding changes you don't want. Note that open-source development in public means leaks are often just visible work in progress. Meanwhile, model variance keeps biting. ISITNerf.org flagged an elevated number of failed coding tests for Claude Sonnet 4.5 while Sonnet 4 looked normal. Practitioners reported goofy mistakes, including misreading or misinputting data pulled via Model Context Protocol (MCP), and some switched models mid-workflow. Others asked for methodology details, noting the chart's variance. Regardless of cause, it reinforces the need for continuous, automated regression testing in agent stacks that combine tools, templates, and fast-moving frontier models. Embodied AI plans ahead. Robots need to replan before they fail, not after. A new arXiv paper proposes scene graph-guided proactive replanning. Compare a current RGBD-grounded scene graph to reference graphs from successful demos. If preconditions for the next subtask aren't met, diagnose the likely cause and revise the plan before executing. This targets the real culprits in long-horizon manipulation. Subtle spatial relational factors like occlusions, reachability, or whether an object is already being held, where post-hoc recovery is inefficient or impossible. The work explicitly avoids rule-based triggers and extensive human supervision, aiming for scalable robustness. Code is set to be released upon publication. 3D content generation is also getting a local to global boost. Mesh Mosaic assembles artist-grade meshes by generating parts and stitching them into coherent objects. The official repo is prepping a public release with instructions spanning PyTorch 2.5.1, CU124, flash attention and custom kernels, pre-trained weights on Hugging Face, and a workflow for segmenting input meshes into connected components before generation. It's been tested on A100, A800, and H20 GPUs, reflecting the compute needed for high-quality geometry. The modeling stack is converging. perception, spatial reasoning, and control in one loop. Qwen 3VL highlights advanced spatial perception with 2D grounding and emerging 3D grounding, long context video understanding with timestamp alignment, and even a visual agent that can operate PC mobile GUIs. Coupled with proactive replanning and better mesh priors, embodied agents can start behaving less like blind macro recorders and more like adaptable operators in a changing world. Security, specs, and surprises. Proven correct code can still be wrong in production, and not just because of bugs. A clear write-up breaks down 3 failure modes for formally verified software. Invalid proofs, rare with mechanized provers but possible, especially with unsafe assume true shortcuts. Wrong properties, like left pad string length instead of visual alignment in Unicode. And wrong assumptions, like binary search proofs, assuming unbounded integers, or algorithms silently relying on sorted inputs, sufficient memory, absence of concurrency, and stable external APIs. The threadbare moral: know exactly what your proofs guarantee and communicate those limits to everyone depending on them. On the firmware front, secure boot isn't secure if the signed payload is a shell. Researchers showed that vendor-signed UEFI diagnostic shells can act as signed backdoors. With powerful commands like memory modify, an attacker with shell access can read-write arbitrary memory pre-OS, achieving a full secure boot bypass while the system still looks like it booted securely. This isn't about malicious keys, it's about legitimate, powerful tools being acceptable to the boot chain by design. Defense here is policy and configuration, not just cryptography, and updates can still break fleets. A widely shared post claimed a software update bricked all 2024 Jeep Wrangler 4E models, an extreme example, if accurate, of the blast radius when OTA governance fails. When coupled with the UEFI shell issue, it's a reminder that the modern attack and failure surface spans from silicon to cloud, with signed and automatic not synonymous with safe. At the application layer, both prevention and analysis tooling are advancing. A modern guide to preventing CSRF in Go lays out current best practices for web developers, a good refresher as browser defaults and frameworks evolve. For defenders and reverse engineers, UGAR, assisting Go analysis and reversing, plugs into IDA 9.2 and detects 5 to 20 times more strings in Go binaries on Linux than IDA alone, and helps demystify interface-type method calls, while openly documenting current failures on stripped binaries and some Windows builds. Secure software is a process, not a checkbox. Offline bidding gets smarter. AdTech continues to be a proving ground for offline decision-making. Traditional offline RL for auto bidding is attractive in theory, but brittle in practice. Bootstrapped value estimation, off-policy learning, and function approximation can create unstable training dynamics. Production constraints make it worse. There's no highly accurate offline evaluator, and online ABs are expensive and risky, so regressions can slip through. A generative alternative, AI-generated bidding, AIGB, sidestep these pitfalls by treating policy learning as conditional sequence generation with diffusion. It avoids bootstrapping, improving stability, and empirically beat offline RL baselines. But imitation has a ceiling. Without explicitly optimizing the real objective, maximize advertiser value subject to budget, performance is capped by the quality diversity of log trajectories, and diffusion models can overfit limited data. AIGB Perl tackles that gap by adding offline reward evaluation and policy search on top of the stable generative backbone. The aim is to retain AIGB's training robustness while directly pushing policies toward the true objective under constraints, all offline. If borne out, this hybrid, generative planning plus explicit policy optimization, could be a template for other safety-critical sequential decision systems where online exploration is off the table. Open analog chips end-to-end. Open silicon is no longer just digital. A hands-on walkthrough shows the full process of designing an analog ASIC and ADC using the Skywater 1D PDK in the Tiny Tape-Out Analog Design VM. The toolchain, Xscheme for schematic capture, Magic for physical layout, leans on TCL for customization. And the constraints are very analog. FET choices dominate, capacitors are expensive, inductors are verboten, and absolute component values are squishy enough that designers aim for stable ratios instead. The community is even working on packaging options, chip on board from JLC and dip castellated boards to make small runs practical beyond bare dies.